One of the top innovations at CES this year was an exoskeleton. Welcome back to Techstination. I'm Fred Fishkin. Joining us from Human in Motion Robotics will be co-founder and CEO Siamak Arzanpour. And also with us is company ambassador and director of lived experience, Chloe Angus. Hi, Chloe.
Hi, Fred. Thanks so much for having us on today.
A pleasure to meet you. Tell us a little bit of background about the company, first of all.
Yeah, so we are Human in Motion Robotics, and we are a company focused on building the next generation and the world's most advanced exoskeleton. We are based in Vancouver, British Columbia, Canada, and we were very honored to have it be our first trip to CES this year.
Interesting. When some people think of exoskeletons, they think sci-fi and stuff like that. But there are some very important real use cases, scenarios here. And you have a personal story with it. Tell me about it.
Yeah, absolutely. The future is now in wearable robotics. It's no longer in the movies. I can contest to that. And also the need for this type of technology is so needed by millions of people, myself included. So to give you a little bit of background about me and how I ended up here at Human in Motion Robotics, I sustained a spinal cord injury in 2015 due to a rare benign tumor that was central in my spinal cord at waist level. I had a bleed at one time in 2015. It was out of the blue. I never been sick in a day, never suffered back pain. And all of a sudden, one afternoon, some tingling on my right toes and a bit of back pain in my left hip. Ended up continuing, and over a 24-hour period, I watched as my legs both stopped working. And doctors ended up putting me into an MRI machine and finding this rare tumor in my spinal cord. And it was at that time that they came to me and said that they didn't know a lot about my condition. It was quite rare. But the result of it was that the bleed had caused enough swelling inside my spinal cord to pinch off all my nerves below my waist, and that I would never walk again. I would go to a rehab facility and I would learn to live my life in a wheelchair. I was shocked, obviously, as most people are when they receive a diagnosis as severe as a spinal cord injury. It is absolutely life altering. In that instant, my whole life changed. I was running a successful fashion design company at the time, walking red carpets and runways around the world, traveling as an independent businesswoman. And all of a sudden, I was facing a life that was so much more limited than I was used to. All of a sudden, the world was not accessible to me anymore from a wheelchair. And that was shocking. I didn't even know a person in a wheelchair until I was in one. And realizing that there aren't cutouts in every corner, or, real, truly accessible air travel, shocked me. But it was as I, learned more about what my condition was like, and that living the rest of my life in a wheelchair, being seated, was going to cause a serious list and a long list of very serious health complications, secondary health complications to my spinal cord injury. So not really having anything to do with my spinal cord injury, but really having to do with living seated and being sedentary. That includes pressure sores, muscle atrophy, bone density loss, problems with bowel and bladder, circulation. And, what a lot of people don't talk about is, the pain of sitting all the time. And I try and explain to people what this feels like to be in a wheelchair. And I often say it's like flying 14 hours in coach. You know how your back feels at the end of that flight? You just want to stretch your legs out, and you would trample the person next to you to get off that airplane. Now imagine living in that airplane seat for the rest of your life. it's incredibly confining, and you do want to stretch out. Your body is meant to be upright and moving as a human being. On top of that, the world goes around at eye level. That's where humans communicate. And being at a lower level than the rest of society, than the rest of my peers, my family, was incredibly challenging for me. So here was all the things I'm facing from a hospital room, looking at a wheelchair in the corner, thinking to myself, it's 2015, there must be something better than this. How am I going to help myself out of this situation? So I got online and I Googled how to help myself. And I found an article online in Popular Science magazine, and it was about this new technology that was going to help paralyzed people walk again, and it was called an exoskeleton. And I just remember thinking like, oh, hey, I'm in the hospital room and my husband and my family are there just devastated, thinking how they're going to help me. And I said to my husband, honey, just order me one of these off of eBay and I'll be back at work next week. That was my solution. But that was very naive at the time. And I didn't realize, this was 2015 and this technology was still in its first generation stage, early stage, and mostly only available in research centers. I couldn't order one off of eBay and get back to work. But the idea was there. And as I continued my journey, my exoskeleton journey and my journey through spinal cord injury, I moved on to a rehabilitation center. And I started asking them there about how else I could help myself. And they were pretty certain that I had a complete spinal cord injury with no chance of recovery. Therefore, they recommended that I focus on my wheelchair skills and my upper body strength. I didn't really see that this is what needed rehabilitating for me. I needed my legs to keep moving. And the research that I had done really showed that this exoskeleton technology, if you could keep people up and moving, they were having some great results. So I continued my search online, and I ended up finding that the rehab center that I was at happened to have an exoskeleton. They just didn't have a program that they used it for. So after much advocating for myself, I was granted 8 sessions to use an exoskeleton at the rehabilitation center that I was at. And even though it took 3 people to get me into it, I found that it was clunky and it was heavy, and I had to use arm crutches and a walker to get up. But once I was moving and I was walking, I walked across a gymnasium floor after doctors told me I would never walk again. And that just was an aha moment for me. It opened my eyes to what was possible. Maybe not was possible with my own physical recovery, but what was possible with technology. And that was all I needed to be inspired to push forward with this injury and to know that there was going to be something for me beyond a wheelchair. Unfortunately, by the end of the week, by the end of the 8 sessions, I realized that the exoskeleton technology in 2015 was in that early stage. The exoskeleton that I used only moved in one direction forward, very robotic-like, didn't have natural gait, wasn't self-balancing, so very hard to operate. And it took 3 people, as I say, to get me in it. And when I wanted to turn the corner, somebody literally had to grab me by the shoulders and turn my whole body to get me going in another direction. So I could see that the technology was amazing and would help me, but I could see that it just needed to be made a little bit better. So again, in my naive state of what my knowledge of technology was at the time, I just decided to reach out to the handful of exoskeleton companies around the world at the time that were making exoskeletons and enthusiastically offer my services to build a better exoskeleton, of which most of them, honestly didn't really respond to and thought their exoskeletons were pretty good, I think. So, but I ended up finding out about 2 professors and a group of students at Simon Fraser University here in BC. And that was right in my own backyard. And they had an idea for an advanced exoskeleton that was what I was looking for. So I went out to meet Dr. Arzanpour and Dr. Park, and they had this concept for an advanced exoskeleton. And it was everything that I was looking for. It was to be self-balancing. It was to be articulate and have natural motion in all directions. And that was it. It was that moment where I met the team that I'd been looking for. And for the team at Human in Motion Robotics, they met somebody who was in a wheelchair, who was a user that they could talk directly to have on as part of the team to help build not just what users need, but what users want in their mobility device. So that was it. We were taking off as Human in Motion Robotics.
Introducing the next generation in personal assistance, ExoMotion. More than just a mobility device, it's a revolution in independent living. With hands-free operation, finely articulated motion, and self-balancing capabilities, ExoMotion provides users with safe, intuitive navigation in total comfort. With seamless integration, our exoskeleton supports users to reach new heights and rediscover the joy of everyday activities throughout their home. ExoMotion delivers organic movement with ergonomic design and flexible programming so users can achieve optimized health and exercise outcomes at home. Getting ready for the day becomes a moment of empowerment as users dress with confidence and step out into the world on their own terms. Whether it's leading a presentation or collaborating with a team, users can focus on their work without being hindered by mobility challenges. ExoMotion means never missing another moment with loved ones. Users can embrace family and friends in a natural, upright position and engage in activities that foster meaningful connections. When it's time to let loose and have fun, ExoMotion enables fluid and dynamic movements to create an unforgettable mobility experience. Dance, laugh, and enjoy independent living to the fullest. ExoMotion. Join us in the future of independent mobility.
Just amazing technology, Chloe. So tell us what your thoughts are about the widespread use of this and how quickly this can happen, because we all know there are many, many people who are waiting.
Many, many people that need to keep moving. And I am always encouraging people that the future is here and is now. And with wearable robotics, they are coming to the market. Be ready for them. Stay healthy, stay active, stay moving, because these devices are incredible. So where we're at here at Human in Motion Robotics, we've just received Health Canada approval and to be able to sell our devices, ExoMotion R, in clinics, hospitals, and research labs, and that will be our first product to market. As I said earlier, for us, we just want to make sure that we're getting our technology, which at this time is the most advanced technology for rehabilitation and really is going to expand the possible, positive outcomes for rehabilitation for people with motion disability. And our goal is just get it into clinics as soon as possible. So that's our first product to market. And we've just gotten Health Canada approval. As I say, we'll have our first clinic devices delivered in May here. And then we have ongoing clinical trials in the US happening right now with the Shirley Ryan's Ability Lab, as well as the VA in Boston. So those are two really exciting studies that we have going on starting this early spring. And that will be our path to FDA approval in the US and being able to help Americans by the end of the year. So that's going to be a really exciting time.
And we all know technology always starts out being expensive because you're building one-offs and or a few at a time. But what's your vision for this being able to be mass produced and really out there in as an affordable solution for the many?
Yeah, that's always been the ultimate goal because I'm a user myself and I'm in this situation. I can contest that living with a disability is incredibly expensive. Most of your indisposable income goes to medical supplies or medical treatments that maybe aren't covered by your insurer or healthcare here in Canada. Um, so the overall vision is that, we're going to create devices that are wearable by everybody and affordable as well. So as you say, when new technology comes out, it's expensive. It takes a lot of money to put into building these initial devices. They are incredibly intelligent and take an incredible amount of intelligence to make these devices actually work in the way that people need them to, that will impact the market in the way that really has that adoption make market change, which is what we need to reduce the price overall of things. It's like when you think about Henry Ford and Henry Ford building the first car, it was big, it was clunky, it was dangerous, and it was very expensive. Only rich people could afford one. Well, look at where we are today, and that's not very many years later since, Ford built the first car. We now have access to this mobility technology, whether you're taking a cab, you're riding the bus, you can do ride share, you can buy a Honda, or you can buy a Lamborghini. That's how quickly market adoption can happen when technology really meets need. When we go on to talk about how people get these devices, how they afford them, there is, thankfully, a growing trend globally around the world to have the cost of exoskeletons covered for people who need them. And that's to me, really shows that these devices work in all of the ways that they need to. So helping to have people be more independent and helping their overall health and wellness. Because insurers don't usually do it out of the goodness of their heart. They do it where it makes financial sense. So we are seeing that there's financial sense in having exoskeletons for people at home. And this is where the entire trend of the global market is going, and we'll continue to push for that. There is an insurance code in the United States specifically for exoskeletons already, and there is a price tag that they'll pay up to $100,000 for exoskeleton technology. And this is the previous generation. So when we're talking about a device like ours, I mean, that's fantastic. So we're really excited about the opportunity for coverage for people for these devices. And that's something that, is really important, that people know that they actually do have support for this technology, but also that as our market grows and as our manufacturing increases, that the overall cost will decrease.
And coming from the design end of things, tell us what your thoughts are about how portable this can really become, because I guess that's one of the keys to a return to normalcy, right?
Yes, absolutely. So what's so important about my role at Human in Motion Robotics, being the director of lived experience, is to bring lived experience, user need, and user want to the development team at the earliest stages so that they know what's important for me and what's important for our customer. And that's independence and it's accessibility. So those are at the very top, and health. So those are at the top of the pyramid of goals of how we create these devices. So the idea is that as we continue development, what I talk to my team about is that I need to use this device my whole day. It is going to replace my wheelchair. I'm going to call it out of my closet and have it sit next to my bed in the morning where I can get into it. I can go about my daily morning routine. I can make my husband breakfast. I can pour the coffee myself. All of these things that I can't do now in a wheelchair. that starts out my day. And then I need to be able to go down my front stairs, get into my car, drive to work, stand to do a speech at a podium, go to the grocery store on the way home, reach the cereal on the top shelf, and load those groceries into my car and come home in the day. So that's what a real day looks like for a person. And I have to go all of those places. As I said, my life prior to injury was walking red carpets and runways and traveling as an independent woman. And I see that for myself again.
And the idea that perhaps the vehicle within a few years will be able to drive itself is another, I guess, plus. It's a robot on wheels as opposed to with
Yeah, well, absolutely. I mean, that's the great thing about all of this technology coming along. It's just going to make our lives easier. I'm also, hopeful that the car that I get into may even be able to charge my exoskeleton on the way to work. So wouldn't that be nice and easy?
Well, this is as good a time as any to bring in the co-founder and CEO, Siamak Arzanpour. Hi, Siamak.
Hi, Fred.
We've been hearing the story from Chloe, some of it, but I want to hear from you what the motivation was for you to get into this area of research, this field.
Well, my background is basically engineering. So I am a mechanical engineer by training, and then through my higher education, master's and PhD, I got into the field of robotics and automation. Um, so I remember in 2014, I was attending a conference in the Bay Area, and the conference was about the technologies related to people with motion disabilities. And there I saw one of the early exoskeletons that I'm sure Chloe explained about. And I remember that day I was talking to some people, wheelchair users, and all of a sudden I saw everybody's moving to one direction. And I followed the crowd and I saw they're gathering around the booth of that exoskeleton company. And I also saw the excitement in wheelchair users when they saw one of their own is getting into an exoskeleton, standing up and walking. It was very exciting for me as well as a person who is involved in robotics and technology. But very soon I realized about the shortcoming of that technology, which was only one motion, which was walking forward, and the users needed to have arm crutches and human attendants for maintaining their balance. When I came back from that conference, I quickly met with my friend, the other co-founder of Human in Motion, Dr. Edward Park, and together we decided to put together a small group of grad and undergraduate students. At that time, I admit I didn't know much about the depth of the problem that we wanted to solve. But we gathered this small group together. We worked on a novel robotic joint that can preserve the articulation that we needed to have in the biological joint. So we went through a couple of rounds of prototyping and testing, and that was the time that we met Chloe. And I acknowledge most of the understanding about the secondary health complications and how these technology can affect the life of people was something that in the beginning we knew part of it, but the depth of it was when we were introduced to Chloe.
A real force of nature, I must say. So together, tell us where things are today, the what you've been able to accomplish from those early days. And it's been a challenge, I'm sure, getting the funding and all the support that you've needed to make this happen.
Yeah, so the funding obviously is one side of the problem. So you need to secure enough funding to make a large enough team because this is a very complex mechatronics problem. It is not just building a robot. The robot has human side. The robot has to walk self-balance. The robot needs to enable the users to do all the complex maneuvers that able-bodied people can do. And motions need to be human-like. People with different height, weight, body shapes, and dimensions get into the robot, and the robot has to safely accommodate all of these variations. So we needed to bring a very diverse group of engineers in the beginning, the R&D team, from the mechanical engineers to software engineers, systems engineers, people who know how to design PCB, integrate sensors to the system, develop algorithms. So for the first few years, the team was mainly R&D team, and we went through multiple rounds of prototyping. The first prototype that we had that could accommodate a person inside was 2018. That robot was called Alpha prototype. So Chloe has a name for it. I don't know, Chloe, if you mentioned the name of that robot.
That first robot, yeah, they call Alpha, and I called Arnie because it was the biggest hunk of power exoskeleton you've ever seen. We used huge motors the team built because they didn't know what they'd need, and it was made out of this big clunky metal parts, and it was a real Terminator. So my pet name for it is Arnie.
But yeah, everything is started from that Arnie. So one of the first obstacles that we had, the roadblocks, was we were looking for actuators. Actuators are a combination of motors, gearhead. We wanted to find something that has the torque, velocity, weight, size that we can actually put it into the exoskeleton and don't make it a really bulky structure. And we couldn't find anything off the shelf because all of these actuators are made for other applications. There's no actuator that is specifically built for exoskeleton application. And we were very disappointed that there is nothing in the market, so we cannot continue. Then we decided to build our own actuators. And the first actuators that we built was for Arnie, Alpha prototype. Over the years, we went through multiple rounds of prototyping. We built our Beta 1, Beta 2, ExoMotion I, and now our product, ExoMotion R. And over the years, the size of the motor hasn't changed significantly, but the power of it is 4 or 5 times more than the power that we had in the Alpha prototype. So that is a kind of perfection that we had in our design over the years. The same thing in sensoring, the same thing in the communication between the sensors, the computer, actuators, the joystick that sends the command to the robot. So that was the R&D piece. And then along with R&D, along with different prototypes that we built over the years, we went through multiple rounds of financing, our Seed 1, Seed 2, and Series A. And government of Canada was very supportive, and we also received funding from government to continue the project.
And I understand you have an office now, thanks to some funding in South Korea as well.
That's correct. So that funding was our Series A, and it was around $10 million that we received. And the goal of that funding was completing the product, which is ExoMotion P. So right now the team is assembling the 10 units, the first 10 units of ExoMotion P. And these 10 units, as Chloe probably told you, we got Health Canada approval. Some of them are going to be used for sales. Some of them are going to be used for clinical studies, and our mechanical electrical safety test that has to be done by third party. So for now, we have specific use for the first 10 units, but we are going to build more this year. We are hoping to increase the sales and also collaborate with researchers that are very interested. We have received many interest from US, Canada, researchers that wanted to use our exoskeleton for different applications. Some of them are in the clinical area, some of them are engineers who want to work on improving some of the methodologies that we have, and these are our interests as well.
Tell us what the biggest challenges you feel you are ahead of you today. How far off it is to kind of achieve the dream that you have, that Chloe has, of really having this out there for people to use every day?
Um, In terms of the technical challenges, if it was 2 years ago, I would say still we wanted to make sure that um, the robot is going to accommodate a larger population, and we wanted to, well, when we started the project, our mindset in the beginning was having a personal device for people with a spinal cord injury, and then a few years down the road, we decided to first go to the rehab market and then to the personal use. So we needed to change the functionality of the robot from a personal use to a rehab version. So for rehab version, you can imagine that different indications will use the exoskeleton, spinal cord injury, stroke patients, TBI, MS, and each of these different groups have different needs. So the robot has to accomplish all of these different groups' needs. And incorporating those software and understanding what are the needs where and how we are going to accommodate it in one single device for all of these indications was the challenge. But now all of those challenges are resolved. Um, our next challenge ahead of us, because ExoMotion P is finished, as I told you, we are assembling the units right now, is going to be ExoMotion R is finished. ExoMotion P is going to start. The P is the personal use version. And for the personal use version, we have a bigger dream. So this device is going to be used as a mobility device, and the level of the safety and compactness, the novel technologies, AI that we want to implement in this version. So these are gonna bring us new challenges that we didn't actually have before. And right now we are working on bringing experts, adding them to our team, and completing our team to have those expertise and knowledge for having an ExoMotion P that all the users want to use. We are building these exoskeletons for end users, and it is very important for us that they like the final products. It's my background, I told you I'm actually coming from academia, so business is important, but at the same time, the human side of that is something that motivates us a lot. Sorry, I'm going a little bit, I'm deviating from the question that you asked, but um, I'm trying to answer one of your early questions about our motivation. So this project is a true mechatronics project. That is something that our R&D team really likes to do. But the human side, when we see joy in end users, when they come and get into the exoskeleton, stand up and walk, interact with their families, that is going to give us an extra reason to work hard and be dedicated to the outcome, the final results that we're going to get from these projects.
Do you see this? I mean, there's a lot of sci-fi of images that come into mind when people think about exoskeletons. Do you see this as kind of for the population at large, those with disabilities and those who may not have them, as kind of a life extending kind of technology and in the long term for us human beings?
Um, so robotics, the basics of robotics were there for many years. And one of the reasons that robotics is boosting right now, well, the technology had its own advancements. For sure, the size of the actuators became smaller, electronics the same. The processors are more powerful. So all of those were something that's 10 years from now, people expected that to happen. What was not really expected was the fast pace of AI, which is giving another dimension to the robotics. And now robotics is booming right now. So to answer your question, I see that for sure. So together with the advancement, natural advancement in production, in novel technologies, I also see AI to come on board and make these robots, give these robots a capability that they didn't have before. And that is extremely important. I see in future what we are doing right now be branched out to different applications for construction, for even for space. So in space, when astronauts go to space, muscle atrophy is a problem. So we can actually come up with a version of this exoskeleton that is specifically for exercise, a light version that we can actually send it to Mars, to Moon, and we are thinking and working on those applications as well. So yeah, I think in future these robots are going to have even more capabilities, and this is the direction that the company wants to take after we finish with the two versions that I talked about, ExoMotion P and ExoMotion R.
Right now, there are a lot of people waiting and waiting for this kind of assistance and help. For more information, where can people go?
We have some information available on our website. But if anybody is interested to learn more about our technology, Chloe and I can answer the emails, and then just I receive many phone calls from end users, and I remember I had a phone call from a wheelchair user that I didn't answer for a week because I was busy, and then I called her after a week, and she was so excited that I returned her call, and I told her I always return these calls because this is important for me to tell specifically the end users about what we do, because it is important for them to know that the technology is coming and they need to practice and be ready for the time that it is available for them to use the exoskeleton. I know Chloe had many phone calls, and she is also answering those phone calls, but it is one of our responsibilities to talk to people, give them information, give them hope that this technology is coming.
Go
Certainly
ahead,
our
Chloe.
inbox has been full since being at CES, and being that we were one of the top 50 picks for 2025 out of 4,500 exhibitors and #1 for robotics. That is just an incredible takeaway for us from CES. And certainly we've gotten a lot of media coverage when we were there, and so many people are reaching out. It's wonderful to see everyone from clinicians to researchers and end users alike. Everyone's so excited about this technology, and can't wait for it to be accessible to them as well. So as Siamak said, we have the website where you can go for way more information. It's humaninmotion.com, and there are areas there that you can reach out to contact us if you're a clinician, if you're a researcher, if you're an end user, or if you're an investor. So all of that information is there, and it's really easy just to click on and sign up. And as Siamak said, we do get around to answering every single one of those. So really excited to engage with people, and thanks so much for highlighting this incredibly important technology, Fred.
Well, thank you and congratulations on all of the innovation there, and more importantly, the heart that you both have in the work that you're doing here. So, Chloe and Siamak, thank you for spending time with us.
Thank you so
Thanks so
much,
much,
Fred.
Fred.